morning. The last class I discussed the halo alkanes and halo arenes. There we have discussed the how to prepare halo alkanes and halo arenes, and also we have discussed some of the chemical reaction mechanism SN1 and SN2. So after that we have discussed the reaction of halo arenes. In today's class, we shall start the new chapter, more interesting chapter in physical chemistry, electrochemistry. We shall start the chapter electrochemistry. What is electrochemistry? It's a branch of a chemistry. It deals with the conversion of electrical energy or a production of electrical energy. You can say production of electrical energy using a spontaneous energy released in a spontaneous reaction. One is the chemical energy into electrical energy. This is the one. Chemical energy is a production of electrical energy using energy released in a spontaneous reaction. And one more thing is by using electrical energy to bring the non-spontaneous reaction. To bring the non-spontaneous reaction. Chemical reaction. In simple word, she deals with a chemical energy to electrical energy and using electrical energy to chemical reaction. These are the two areas the electrochemistry deals. So before going to the chapter, see what is its importance? Why want to study the electrochemistry? This is a question. So the electrochemical principles are used in various fields. The production of large number of metals. Already we have studied in metallurgy, the production of aluminum, followed by Hall Herold process. There you are using electrical energy, and the chemical like sodium hydroxide, chlorine, these are all prepared by using an electrochemical principle. It is used in the production of the electrochemical principle are used in the production of large number of metals. One, and also the large number of chemicals like sodium hydroxide, chlorine, etc. It's also used in the batteries or fuel cell. There, which principle works? The electrochemistry principle works. The transfer of signal from the blood cell to the brain, brain to the blood cell is a electrochemical origin. Therefore, the study of electrochemistry is a very important. It's a theoretically as well as a practical aspect. This chapter is very important. The point of examination for even the board exam, competitive exam, this chapter is very important. Try to understand the concept of the electrochemistry. So before going to this chapter, before starting the chapter, you should have some knowledge, because the electrochemistry works on the chemical reaction or redox reaction. A redox reaction. The electrochemistry works on the which reaction? A redox reaction. Because last year you have studied what is redox. So there is a reduction and oxidation. And what is oxidation? See, for example, suppose you have a copper sulfate plus zinc. Copper sulfate plus zinc. What is the reaction here? Zinc sulfate plus simple reaction. Last year also you have studied the redox reaction chapter. Yeah. See what actually the reaction is here. Here, the copper sulfate means in a copper is in a plus 2 state. The copper sulfate is the copper is in a plus 2 state. The zinc is in it's an element. Zinc is a 0. Zn is a 0. Oxidation. The element its oxidation state is a 0. In the product, what we get? The Cu2 plus is converted to Cu. Zn is converted to the reaction. So before the reaction, the Cu2 plus and Zn0. In the product, Cu0 and Zn2 plus. Here, what is oxidation? Which one is oxidized? Which one is reduced here? So what is oxidation? The removal of electron is called oxidation. The removal of electron is called oxidation. Here, which one is oxidized? The Zn going to Zn 2 plus 2 electron. The Zn is oxidizes to Zn 2 plus. What is oxidation? The removal of electron is called oxidation. Or you can say increase in oxidation number, you can define in another way. Increase in oxidation number is also called oxidation. Here the oxidation number of the zinc is 0, now it becomes plus 2. Oxidation number is increased by 2 units, therefore it's a oxidation. See now, look the oxidation number of Cu2 plus takes this 2 electron becomes Cu. See, this is called reduction. What is reduction? The addition of electron, the reverse of the oxidation. The oxidation is removal of electron, reduction is addition of electron. Oxidation is the increase in oxidation number, reduction is the decrease in oxidation number. The Cu2 plus is converted into the Cu. Its oxidation number is decreased by 2 units. So clear? Another example I have given. Suppose you have the acid Ca plus magnesium plus magnesium. What is the product you get? A magnesium chloride plus a chlorine hydrogen gas. So what actually is the reaction? What is the reaction? Here the H plus ion, 2H plus ion, or you can say either Mg0 is converted into Mg2 plus Mg2 plus the 2H plus ion is given rise to H2. 2H plus ion is given rise to H2. This is a how many electron it has lost? 2. How many electron it has to gain? It has to gain a 2 electron. What is actually net reaction is what? Net reaction. This is a spectator. This is chloride and this is spectator. Here also it's a -1. Here also -1. Suppose it's an ionic reaction. See how do you write? 2H plus ion plus Mg giving rise to Mg2 plus H. This is the overall reaction taking place here. Here magnesium is oxidized. H plus is reduced. H plus is reduced. So here, see, I can give a lot of equations. So you have studied in your studied in figure. So chlorine F2 plus 2 NaCl, already you have studied in the halogen. The chlorine is the strongest oxidizing agent for all the known elements. So what is the reaction we are expecting here? The F2 is converted to F minus 2 giving F plus C. Which one is oxidized? Which one is reduced here? The F2 takes the 2 electron, giving rise to F minus. F2 take the 2 electron, giving rise to F minus ion. This is what? This is what? A reduction. See, reduction means the gaining of electron. In the reduction reaction, where the electron you have to write, in the reactant side you have to write the electron. So gaining of electron means you have to write at the reactant side. And what is the oxidation here? Here, the Cl minus ion, 2Cl minus ion, 2Cl minus ion, giving rise to what? Cl2 plus 2. No. Cl2 plus 2. This is a chloride ion is oxidized to chlorine. The chloride ion is oxidizes to chlorine. The chlorine is reduces to chloride ion. Which one is oxidizing agent? The chlorine is an oxidizing agent. It oxidizes the chloride to chlorine. Chloride to chlorine. I think it's clear. What is oxidation? What is oxidation? A removal of electron. So here we have removed the 2 electrons from the chloride ion. The Cl minus ion is converted into the Cl2. Here it's a this oxidation state is -1. It's converted into 0. Oxidation number is increases. So this is very useful for balancing the inorganic reaction also. So you can balance the inorganic, you can write the any reaction without any problem. So therefore, this concept is important in electrochemistry as well as it helps in writing the inorganic reaction. So try to learn. Actually, the ionic reaction are very easy. So I will talk 1 minute about the ionic reaction. Actually, ionic reaction. What is ionic reaction? F2 plus 2Cl minus ion giving rise to 2F minus ion plus Cl. Here, ionic reaction means what? The total number of charges on the reactant side and the total number of the charges on the product side should be same. After balancing the reaction, you have to check the ionic reaction is balanced or not by checking the charges on the both side. Clear? Okay. So anyway, to try to learn this concept, actually it's the helps to write the inorganic reaction. And this is the this concept is very important in your chemistry because the this the most of the time inorganic reaction you are going to study is a redox, and this redox concept is helps to understand the electrochemistry. But with this knowledge, we shall move to the electrochemistry. So, what is electrochemistry? I already told. What is electrochemistry? It's a branch of a science deals with the conversion of or a production of electric current by using the energy released in a spontaneous redox reaction. It's a chemical energy you are converting to electrical energy. One way, that's one device that you are going to study. In another ways, you can convert the or you can bring the a non-spontaneous redox reaction by using your what? Electric current. Here, what is that mean? So I will discuss this example. See, you have coming across with two reactions, two words: spontaneous and non-spontaneous redox reaction. Which is spontaneous? Suppose you have a copper sulfate. If you add the zinc rod in a copper sulfate, spontaneously reaction is taking place. Spontaneously a reaction is taking place. This is called a spontaneous redox reaction. It's called spontaneous. The reverse reaction. The zinc sulfate plus copper gives rise to no product. This is non-spontaneous. The reverse reaction is a non-spontaneous. What this reaction is a spontaneous by dipping the zinc rod in a copper sulfate solution. Copper sulfate is a blue color. So it's the color of the copper sulfate is discharges. The reaction taking place spontaneously. There are some energies released. That energy can be converted into electrical energy. One. Another is a non-spontaneous. Suppose you want to do the reverse reaction. You cannot do this reaction. This reaction is not spontaneous. There you have to use electrical energy. So the electrochemistry deals with the what? A production of electric current in a spontaneous energy released in a spontaneous redox reaction and the use of electric current to bring the non-spontaneous redox reaction. Okay, with this background, we shall move to the electrochemical cell. Electrochemical cell. Electrochemical cell. What are the electrochemical cells? So there are two types of electrochemical cells. Already we have studied the spontaneous redox reaction. Spontaneous redox reaction. There the energy is released. Any process in the nature is spontaneous means its free energy is decreasing. Last year you have studied in a thermodynamics. Suppose any process, so wind blows, spontaneously taking place, their energy is decreasing. That energy can be converted into any form. You know the wind will convert that energy into electrical energy. Here also, this process, this reaction is taking place spontaneously means that free energy should be decreased. You can convert this free energy into electrical energy. The device is called the galvanic cell. A galvanic cell. What is a galvanic cell? It's an electrochemical cell. What it does, it produces the electrical energy by using a energy released in a spontaneous redox reaction. What is a galvanic cell? It's a device or it's an electrochemical cell. It produces the electrical energy by using a energy released in a spontaneous redox reaction. Already I told, if any process is spontaneous in nature, there is free energy decreases. Its energy decreases. You can convert this energy into any form of the energy. In galvanic cell, this convert this energy into electrical energy. Clear? So this is called a galvanic cell. It's an electrochemical cell which produces the electrical energy by using an energy released in a spontaneous redox reaction. One more cell is that an electrolytic cell. You have studied already I told you, Hall-Herold process. Hall-Herold process, the production of aluminum. What you have done? You have converted Al2O3 to A. Carbon dioxide. Here you have produced this is a non-spontaneous reaction. This is a non. Then how did you done it? See how did you do it, this reaction? See, by using a electrical energy. By electrical energy. This type of electrochemical cell is called electrolytic cell. Electrolytic cell. So that means the electrochemical cells are of two types. One is a galvanic cell, which converts the energy released in a spontaneous redox reaction into electric energy. And electrolytic cell. The electrolytic cell means what? It converts, brings the non-spontaneous redox reaction. This is a non-spontaneous redox reaction by using a electrical energy. Okay, so we shall discuss in detail. Last year, we have studied. Last year, you have studied the Daniels. Daniels. What is a Daniels? So it's a galvanic cell. See, in a Daniel cell, a galvanic cell means what? It produces an electrical current using a what? A spontaneous redox reaction. So actually, what is the Daniel cell consist of? The Daniel cell consists of zinc rod. It's a zinc rod. It's a dipped in a zinc sulfate. It is ZnSO4 solution. A zinc rod is dipped in a zinc sulfate solution. And another is